We'll officially get started in just a few minutes, but we're very privileged today to have our own department chair, Bob Harrington. I tried to have ChatGPT write the intro, and it covered many things, too many to cover, but amongst many accolades. Did you receive a lifetime research award from Duke before, or did you make that up?
Make that up.
Okay, well, I wouldn't. It was completely believable given the amount of things you've accomplished. And currently, you're having the president of the American Heart Association. But I want to speak also more broadly. We'll get into all the stuff you're going to share with us on your perspective. But I remember back when I was a fellow, a resident, I chatted with you. I know it's kind of long-ish ago.
We were both a little younger.
Yeah. And but tell me, well, who is this new chair here? But you laid out your vision for the department and for medicine. I thought that's a really great vision. And also, there's a place for me in my various biased perspective for computational informatics, data science. This guy's got a good perspective. And also something that I found as inspiring as all the great research and clinical work you've done is you talk about, hey, this story, you're the department chair coming in, somebody stops you and you say, where are you going? You're going to the cath lab. And they're like, what's wrong with you? You're the chair, you don't got to do that anymore. And what did you say to this person?
I said, that's who I am. I'm a doctor.
And I thought that was a very inspiring on multiple levels to pull it all together. You could go straight into your talk, or if you want to maybe just tell a bit more on an informal level. I think people are really here looking for
I'm
a
going to do
chance
that
to
actually in my
Q&A.
talk because I figured that I'd introduce myself to many people. And of course, I made the cardinal mistake of coming over here that I asked the division chief, Dr. Musin, what's the format? And he told me one thing. And then I came over here and actually talked to the people that run the colloquium, and he told me something completely opposite. So cardinal mistake, why would I have checked with the division chief? I should have checked with you first. So
It's a dynamic, self-organizing system, but we'll make it work.
So what I thought I'd do is that I was going to give the typical, 40-minute talk, and I'm not going to do that. I'm going to maybe go through some of the highlights of things I'd like to talk about. I'm so used to being with a clinical audience that I always show my disclosures. So I am an active researcher. I am an active consultant. I do serve as a member of the board of directors of the Heart Association. But I put this up there, and I think cardiovascular medicine is a data science, and this could be medicine as a data science. But because I'm a cardiologist, I focus on it because that's where I take most of my examples from. And most of us who are in clinical medicine, we think of cardiology, for example, as a biologic science. It has anatomy, it has physiology. We think about pathophysiology. But what I want to really get you to think about, and this is a talk I often give for a clinical audience, I think if you think about cardiovascular medicine only as a biologic science, we're going to limit our thinking about what's possible. And I see that the real possibilities in clinical medicine are coming from the interface with data science. Because it's going to be, if you think about it, the real wins, both at the discovery level as well as at the policy level, are going to be through the use of data. And that those people who are best able to leverage data for either discovery up through policy are going to be the real winners. Again, this is not an audience I have to convince of this, but when I talk to the clinical audiences, I often will make the plea that what we need are clinicians who both think biologically and computationally. And as all of you know, that's not an easy sell because most clinicians think biologically and are less facile with thinking about data. Now you collect a very unusual breed of clinicians over here because this is your natural inclination. But I can tell you from many years of working in clinical medicine, that's not, what you do is not typical. And the kind of clinicians that are part of Beamer, biomedical data science, and other groups on campus are not the norm. So I was going to do 4 things here, but maybe I'll do 2 of them. And then we can open it up to questions and commentary, et cetera. I'm going to give you my background on why I care about this and why I've actually cared about this for, as Jonathan has suggested, a long time now. I'm going to give you some examples of big data cardiovascular medicine, both in research and clinical care. Not so much that we're going to go into the depth of what those examples are and how the data was generated, which is often, I suspect, the topic of your colloquium, but really to get you to think about, okay, how might I interface with clinicians and how might I begin to think about the problems at hand and also some of the solutions at hand. My focus, because I'm a clinical investigator, I'm not a basic scientist, will be on clinical medicine and on clinical investigation, not basic science. So for those of you who run laboratories and are interested in how this kind of plays out in the basic science world, just forgive me, I'm not going to cover that, although obviously it's critically important. I'd like to talk about AI and cardiovascular medicine. I'd like to talk about education training, but I'm going to skip those and really just try to focus on the first two topics. So my first disclaimer, I am not a data scientist. I am a clinician investigator who uses the tools of data science and who interacts with a lot of data scientists to do my work. And my role in this goes back, Nigam said back into the 70s. It doesn't quite go that far for me. It goes back into the late 80s, early 90s. When I was a clinical fellow at Duke, I then spent, after my clinical training, including training as an interventional cardiologist, I spent 2 years in what was then called the Duke Data Bank for Cardiovascular Disease. And I'll tell you about that. But that was largely a group of very few of us in those days on campus at Duke who were clinically trained, but who worked with a group of software engineers and computer scientists and biostatisticians to really gain insight into what was emerging as this intersection of computers and cardiovascular medicine. I was a faculty member and I was at Duke from 1990 to 2012 when I moved west. I was in the data bank in the early days. And then I was a founding member of something called the Duke Clinical Research Institute. And I was the director of the Duke Clinical Research Institute before I moved here. In my group at Duke, one of the real secret sauces of the Duke Data Bank and then of the Duke Clinical Research Institute is that was really clinicians and data scientists. So for example, in the group, we had about 100 clinicians working in the DCRI. We had over 120, 130 biostatisticians. And so there was really this nice mix of quantitative people and clinical people. I came to Stanford in my current role in 2012. And as Jonathan indicated in his remarks, he found a like-minded chair in the seat because I was really interested in what was going on in the Beamer world. I was very interested in informatics, very interested in biostatistics. And we've made huge investments in both of those topics over the course of the last decade. With Ken Mahaffey, we helped create the Stanford Center for Clinical Research, which is now a group of about 100 people working out of the Department of Medicine on clinical research issues, along with Doug Owen and Mark Cullen. I was one of the founders of the Population Health Science Center, which is now under the direction of Melissa Bondi. We created the Center for Digital Health. Ron's here, athlete representing the CDH. With Chris Longhurst, we helped create the Clinical Informatics Fellowship Training Program, which is run out of both medicine and pediatrics. And with Kevin Schulman, we helped to support the creation of the Master of Science in Clinical Informatics Management. Those are all the kind of things over the last decade that we've done to invest in the data sciences. And I think that there's still a lot more to do. We could talk about that during the Q&A period. On the national scene, I'm very involved at NHLBI, very involved at FDA. I've chaired the Cardio-Renal Advisory Committee a couple of times. Jonathan indicated I've been president of the Heart Association, and I'm on a variety of working groups currently for NHLBI, FDA, and NAM. The most recent one I'm joining is through the Reagan-Udall Center, which is an independent agency that advises the FDA. I'm going to join their working group on trying to understand what the FDA should mean when they talk about real-world evidence. So more to come on that. I could come back at some point, Jonathan, and talk about the work that group's doing. Well, I put this up. Some of you will know some of the people in the picture there. This was the 25th anniversary of the Duke Data Bank for Cardiovascular Diseases. And I'll tell you the story of the data bank in a few minutes. But in this picture, you see some people who I suspect you may know well. Frank Carroll, who was chair of biostats at Virginia, then at Vanderbilt for many years, is this person here. Magnus Oman is next to him, well-known clinician investigator. Some of you may recognize Rob Califf, the current commissioner of the FDA, was the director of the data bank in those days. Liz DeLong was the first chair of biostatistics and bioinformatics at Duke. And this guy back here with the brown hair is actually me. when I had just finished my fellowship and joined the Duke faculty. For those who know Dr. Califf, I always like to point out in this picture, it was the day of a picnic, and you can see Dr. Califf has both mustard and ketchup stains on his pants here. If you watch him testifying in front of Congress last week, he looks much better than he did. And he was one of the founding biostatisticians, along with Frank Carroll, Terry Lee of the data bank. So this was the 25th anniversary of the data bank, and we were a small group at the time. When I joined the data bank as a fellow, we were about 25 to 40 people. And when I left DCRI after having served as the director, we were 1,300 people in the research group. So a lot of growth over the course of those years. And Nigam knows the story because he's heard me tell it several times, and a lot of the work that went into some of the green button really comes from ideas that I learned from this gentleman. This is Dr. Eugene Stead. Dr. Stead is one of my medical heroes. He died in 2005, almost reaching 100 years old. And Stead said this in 1972. So think about this quote here, which I always love. Chronic multifactorial disease problems can be studied, but not by the methods of the present or past. If one wishes to create useful information, computer technology must be exploited. Now, you can say that today, and people would say, well, of course, that's true. He said this in 1972 in a speech to the American College of Physicians called The Way of the Future. And what Dr. Stead did, which you'd get in trouble for today, Duke and he were granted one of the original myocardial infarction research center branches from NIH. And this was to really try to understand myocardial infarction at multiple centers around the United States. And when Stead got the money, the story is that he said, well, that's an interesting question that they want us to study, but I'm gonna do something different. And he took the money and bought a computer, which at that point filled up much of several rooms on the 7th floor of Duke Hospital. And what Stead was interested in, this was in the late 1960s, what Stead was interested in is, could you take the everyday encounters that doctors have with patients and begin to aggregate that in a way that the human brain can't do, analyze that, and then have available at the bedside information based on that aggregate experience rather than recollection of experience that is how most clinicians practice medicine. And again, today you'd say, well, that's not really that forward thinking. This is in the 1960s that Stead was thinking this way, which I find really extraordinary. And when I left Duke, if those of you have been in my office, this picture hangs in my office. This is the original Duke databank right here. As people came into the Duke CCU, the information was written down by the admitting physicians. That's why you see the different pens, the different penmanship. And then that information was extracted from these notebooks and computerized, put into a database to begin to understand how you might use aggregated information. And one of the first major papers that, again, Nigam and Allison will appreciate that came out of the data bank was something called the prognostogram, which Nigam has updated to a current world view of the prognostogram was designed to really answer a really, really important question in clinical medicine is, how do you take non-randomized data and gain inference about treatment decisions? And this was something that the data bank faculty, the clinicians, the biostatisticians grappled with throughout the 70s, is how do you take this data that was, decisions were picked by cardiologists. And in this particular case, what they really focused on was coronary artery disease. So blockages in the coronary arteries. And at the time, medical therapy was the predominant way that we treated people with coronary artery disease. And then in the 60s and 70s, it was the advent of coronary artery bypass surgery. And I haven't said angioplasty yet because that's not on the scene yet. That doesn't come for another decade. So in the first decade of the data bank, they were very interested in trying to understand, which patients gained benefit from medical therapy and which patients gained benefit from bypass surgery. And so when I was a fellow, we would, again, go to this room with the big computer, and we would, after you had done the heart cath, you would go to the room and you would enter your data into the system. And Jacob knows the story, because I would say, then you'd literally press the button and you would get the prognostogram that would look at the variables that you put in, would basically use, pretty straightforward multivariate analysis and provide you what patients like yours did. All these phrases sound familiar for those of you who have listened to Nigam talk about the gray button. That's what we did. And we got this printout. Again, remember, this is more than 30 years ago. And we were expected to go to the bedside of the patient with our prognostogram and have what nowadays we would call informed patient decision-making. We provide them the data and say, hey, for every patient like you, when we choose medical therapy at the end of 5 years, this many of them are alive. And for every patient, 100 patients like you who we choose bypass surgery, this many patients are alive. And it would form the basis of the conversation that we were going to have with that patient. And I got totally hooked on this in the data bank at being able to utilize information in a way that was not just recall, but was based on the experience of every patient that had come before the patient that was in front of me right there. And so this was how I really got interested in the topic. When I joined the data bank as a fellow, I was actually Rob Califf's research fellow. In those days, it was literally one fellow a year in the data bank, because this was not the most popular thing to do back in the days when I was a fellow. Most people wanted to do something fun like molecular biology, ion channel research, and all the kind of things that were really hot at Duke at the time. In fact, I went to Duke to be a molecular biologist. I went to Duke to study the molecular biology of clotting. And what I was interested in was working in the lab of a guy by the name of David Sain, who studied the adhesive proteins of coagulation. So fibronectin, vitronectin, those sorts of things. That's why I went to Duke. I was also going to be an interventional cardiologist. This is the early days of interventional cardiology. No stents, very few drugs to prevent things like thrombosis. And in one of my early interactions, I was a fellow in the Duke cardiac care unit with Dr. Califf, and we're doing what fellows did in those days. We would walk down to the cath lab with the attending, and because none of the attendings knew how to use the machine that played the cath films, so they always had to take a fellow with them. And so I would go down with Dr. Califf, and on the way down there, you're thinking, what did you have to do? Ron's thinking, no, you just pull it up on the computer and you look at it. We had to go down and actually we had to go to a library and sign out the film, which is these big canisters, and load them up in the machine and look at the cath films. And so you have a lot of downtime, and Califf asked me what I was going to do with my life. And I told him. He said, my God, that's the dumbest thing I ever heard. And for those of you who know Dr. Califf, that's the kind of way he gets the Socratic method going there. And what his intention was to get me to think, how are you going to be an interventional cardiologist and be somebody who is running a basic science laboratory? And then I didn't realize till years later, anytime, this is particularly for the trainees, the postdocs, the fellows, the residents, anytime someone senior says to you something like this, always realize they have a secondary agenda. Because then the next thing he said to me, well, let me tell you what's going on in the Duke data bank. And,
a great opportunity right here.
We need some people who understand thrombosis, because we're getting ready. This was going to be this era of thrombosis research. We're getting ready to do this big study in myocardial infarction called GUSTO. Where we're going to really try to understand, is it this new fancy bioengineered TPA that works, or this old-fashioned streptokinase that works? And so after a lot of back and forth, and I ended up not going to David Sain's lab, but I ended up going to the data bank. And one of my roles in the early days of the data bank was, because I was trained in the laboratory, I would actually, while we were experimenting with all these new drugs, thrombin inhibitors, glycoprotein 2B3 inhibitors, ADP receptor antagonists, direct thrombin inhibitors, factor 10 inhibitors, all these interesting drugs, part of my job was to do the translational piece. That had not really been done out of the data bank. So I would do these cases in the middle of the night. go up then to the hematology lab and run flow cytometry, play navigation studies, to begin to understand, what was the role of these drugs in the course of taking care of patients. But this was a paper that Califf wrote in 1981, which I think is really important to think about. He wrote this with Bob Rosati, who was one of the founders of the data bank, a cardiologist. He said, in the future, data banks will provide a reference library for each patient with chronic disease. Proper interpretation and use of computerized data will depend as much on wise doctors as any other source of data in the past. And I want you to think about that, because it's one of the reasons that I feel so passionate that we really need clinical people with computational training. Because what we really need to do is bring these two worlds together. Nigam Abraham Verghese and I wrote a paper in JAMA a few years ago that I wanted to build off a famous Stead quote. Stead would always, when presented with a vexing case, he'd say in his very high squeaky voice, he'd say, well, this patient needs a doctor. And what Stead meant was that that patient needed somebody who could sift through all the BS, could sift through all the information and arrive at some logical steps forward. And so Nigam Abraham and I wrote a paper, what this computer needs is a doctor. Actually in JAMA, I think changed it to what this computer needs is a physician. But it was building on the Stead comment and it was really this notion that what you needed was to bring clinical expertise to bear. So why am I still interested in this today? And you don't need me to tell you things about like how do you define data science, et cetera. But the clinicians do ask, why is this such a big deal today? Like, why is everybody talking about this today? And I think it's because of three fundamental issues, none of which are very new actually, but are all come together at the same time. The first of which is that we have enormous amounts of data, but that's not necessarily new. For those of you who've read sort of the lay books on big data, that as I understand it, one of the first big data usage was to create the weather charts and the wind charts for the shipping trade to work around the globe. So it's not necessarily new concepts, but now everything can be put into computerized form. And we can now start to bring together, and I think the part that gets clinicians the most excited is that you can start to bring together what I've called disparate sources of data. You can bring imaging and clinical data together as opposed to looking at them side by side. You can bring basic laboratory data on top of that, genetics data on top of that, and begin to maybe understand disease, therapeutic choices in a way that is so much more advanced than what I talked about with things like the prognostogram. The second, as you know, is cloud computing. This really changes when you have computing power that allows you to bring together all this data and analyze it. In my early days in the data bank, going back into the 90s, as we started really we were making the transition from the Duke Data Bank, the Duke Clinical Research Institute, and we really got involved in the coordination of large-scale clinical trials around the globe, trials that enrolled 10, 15, 30, 40, 50,000 patients from 1,000 centers around the globe. So enormous amounts of data coming into, this weird group of cardiologists in Durham, North Carolina. When we were running some of the analyses, we would link together we'd tell everyone to leave your desktop on when you went home for the night. And we would basically create networks of computing power. And we would tell everybody, but you got to be out of the building by about 7 o'clock. We don't want you working on your own computer. We need everybody's computing power. Think about that. Getting all those doctors to actually do what you told them to do. And so, no, somebody like Jonathan would be coming in at 9 o'clock to see what's going on. So it was interesting as we move into an era of cloud computing, the things we could do that we couldn't do. And you know the story about advanced analytic methods. I love this picture. Maybe I'll show a couple more slides, Jonathan, and then stop. This is a great article written about 10 years ago now by Griffin Weber, who some of you may know, informatician in Boston, was at Harvard and MIT for many years. And I use this picture a lot because I think it creates, particularly for a clinical audience, a great visual. He calls it the tapestry of data, and how you think about all of the various forms of data that are available from which we might be able to gain insights into human health. And it's really, I think, a very forward-thinking piece. And he talks about bringing to bear environmental data. He talks about bringing to bear exposure data, wearable data, in a way that then starts people to think, yeah, you're only in the healthcare setting on average about 1% of your year. Well, where's the data from that other 99% where I can gain insight into your health? And I think many of you knew the late Sam Gambier, our chair of radiology here. And Sam, like Stead, was a visionary thinker. And there's a few papers that Sam had produced shortly before he died. This was one of them, where he's starting to think about achieving precision health. And what he's talking about is, how do you take the ideas of Stead, of aggregating data, the ideas of Griffin Weber of bringing together disparate sources of data, and how do you bring this all together in a way that it can be informative? And I think if Sam were still alive, that we would have made here at Stanford more progress on some of these notions, because he was such a creative thinker about how to bring really different sources of data together. Many of you know that Sam was working on things like smart toilets to be able to gain insight into daily waste. Well, guess what we did throughout COVID? We began I started my day looking at wastewater data to try to understand what was going on in the local environment. And that turned out to be a very clever way to really think about, well, what's going to be the risk of infection in a community, in a dormitory, in a hospital. And Sam was thinking about that. He was thinking about it on the individual level, but he was thinking about it. And I'll close with this one, Jonathan, that when something makes it to the cover of The Economist, you know it's important. And in the last decade, The Economist has had two issues devoted to data. One was about 10 years ago, where the cover was the data deluge. And if you've not seen it, these are worth pulling out, because they were very forward thinking. And the data deluge, I think, is a great visual. But they also pointed out in that article, in that series of articles, that whatever field you were in, those people who figured out how best to harness that data deluge were going to be the people who made the best insights into the law, medicine, business, et cetera. And then about 5 or 6 years later, they published the next issue, where they now refer to data as the world's most valuable resource, doing a riff on fossil fuels here, and saying that it's not oil that's the world's most valuable resource, it's in fact data. And so I think that that's where we are in 2023 and looking forward. For clinical medicine to move forward, we need to take ideas that were old, but now use the tools that we have today that allow us better insight into the presentations that our patients have, the diseases that our patients have, the public health questions and problems that we all are faced with. And we need to use the new tools that all of you represent to be able to solve some of these real problems. So as Mark knows, Nigam knows, Ron knows, Jonathan knows, because they hear, Professor knows, because they hear me talk about this all the time. I am so excited by what you all do. And I think that the best steps forward in our ability at Stanford to make a difference in people's lives, because that's what we're here for, is to make a difference in people's lives, is going to come from all of you. And I just want to be around to use the tools that you all generate as I do my own research and thinking about large-scale clinical trials. How do you combine large-scale information from around the globe? How do we accelerate clinical trials by using pre-existing data, for example, in ways that we've not been able to do? So I've been at this a long time, but I'm as bullish today on this topic as I've ever been. Again, as Mark specifically knows, and Nigam knows, we're going to be making huge investments into these topics over the next few years in the Department of Medicine. And I look forward to working with all of you. So thanks for having me, Jonathan. I'm happy to open up questions, and we can do the rest of it some other time.
Fantastic. Why don't we give a quick answer? We do have Q&A, or would like to engage in discussions. Why don't we just let them run with it? So, Andrew.
Ramsey, one of the cardiology fellows. Two questions that I think are worth exploring. I'd love your insights on is one, thinking about this through the equity framework, which I feel like isn't Next slide, okay.
Further on, I had this in there, yeah.
Yeah, and so I'd love to hear your thoughts on that. And then the second thing is, how do we make this more usable and accessible with, the September guidance on software as a medical device and all these different barriers that don't have solid frameworks of interpretation for IRBs and this and that, and then I'm on my 5th round of comments with it, right? Just trying to figure out how to do this and how to streamline it.
Yeah, so the first one in some ways is easier because a lot of people are thinking about the equity question. And I would put back to you all that there is a paper that came out from Amit Kara and Russ Altman, which points out that there's something like 30 states in the United States that have not contributed data to currently used AI in health algorithms. That's a problem. And particularly, where are those states? Well, you know where they are. They're in the Southeast, and where there's a much more diverse population than there is in the states that use it. And guess what? Where does most of the data come from? California, New York, Massachusetts. Why is that? Well, that's easy to get data, right? It's where all the universities are. So I think we as a community, and I'll push back to you as a community, because you guys do this work, is that we have to be more, and we have to be more equitable. I think I saw Tina here. Tina talks about this. Nagam talks about this, is this whole notion of how do you create fair and equitable data sets? We have to be more inclusive for sure. If you even look at the globe, where's the data come from? The US, China, the UK, Germany, a couple other countries, but it doesn't come from the globe. Where's all the data from Africa? Where's all the data from the Middle East? Where's all the data from South America? I mean, so there's whole parts of the world that we're not getting data from. And I would put that back collectively on all of us. So we have to do a better job of that. And then we have to create models and test models to make sure that there's not unintended consequences, because we know there will be if we're not vigilant. And I heard that Mike Pfeffer was recently here, and Mike and Nagam in their roles at SHC, we talked about this a lot. Are there going to be unintended consequences of models that we're trying to put into place? Are certain groups of patients going to be disproportionately affected in an adverse way? And I think we got to be aware of that. That's really important. In my own work as a clinical trialist, it's a big deal. I mean, we're trying hard to increase the number of women in clinical trials, for example. What's the single best predictor of how many of having large numbers of women in a clinical trial in cardiovascular medicine?
Female PI.
There you go. Female PIs. So you got to have people who look like the people that you want to study, designing clinical trials, designing clinical studies, acting as principal investigators. And it's actually very striking as to you get women investigators leading the project, you get more women in the trials.
One thing, Google search for California Attorney General Hospital CEO letter, and a draft will come up. Our state is amongst the most advanced in asking health systems, and I want to summarize it, just search for it, taking bias and equity in data-derived products very seriously.
Yeah, thank you for bringing that up. And then your other question has to do with, I'll call it the regulatory framework for all of this stuff. And I know that you're deeply involved in health policy. This is where we need policy work, right? And I think on one of my early slides, I point out, I think we're going to enter into an era where policy is going to be more informed by data if we do it well. When you listen to Caleb speak, this is what he talks about. How do we actually use data to inform regulatory policy? So for example, they're just going through the final reviews of updates on what's called GCP, good clinical practice, which is the guidelines for how we all do human experimentation, how we all do, which is what clinical trials are. They're experiments on human beings. And so that's all going to be updated, trying to bring it into a modern framework. And I don't want to say more than that because it's not been released yet, but those processes are going on. As you probably know, biodesign has now created a whole new avenue of work under Josh Mackauer, dedicated to understanding regulatory policy for tech. And so biodesign hopes to be, just like they teach people how to invent, they hope to have a whole separate line of work where they're doing hardcore regulatory policy or research that they hope can then influence policy. So more to come on that. They've just hired a new faculty member who will lead that effort in regulatory policy.
I think actually online, Walter Sujanski has had Walter, you want to ask your question?
Yeah, sure. Can you hear me, John?
Yeah, go ahead.
All right, great. Thank you. Thanks, Bob, for a terrific talk and introduction. And of course, by the way, I'm Walter Sujanski. I'm a graduate of the program from eons ago and an adjunct faculty member now. And I'm thrilled that you personally are so interested and involved in this area, and the Department of Medicine is so interested and involved in the area. My question is somewhat related to the previous questions, and that is, I get asked when I talk with physicians who are somewhat knowledgeable about this area, about the relationship between kind of big data and machine learning versus clinical trials. And I get asked, well, this is all, big data and machine learning is by definition observational. And don't we need, isn't the foundation of our evidence-based medicine world, doesn't that require RCTs and clinical prospective trials and so forth? So how can big data and machine learning really provide us guidance in those areas? And I'm curious if you sometimes get a similar question and or what your answer to that question would be, given how much experience you have in both prospective clinical trials and sort of the more observational big data / machine learning types of studies.
So Walter, first off, thanks for asking the question. And it is something I'm asked, well, why do we need to do these big trials anymore? We got all this data. Can't we just figure it out? And this would be a great one for you guys to argue with me about. But to date, the math just doesn't add up to be able to draw reliable causal inference from non-randomized data. It just doesn't. And in cardiovascular medicine, I'll give you dozens of examples of when people have tried that and it just doesn't work. I've made reference during the earlier period to Greg Fonarow, the chief of cardiology at UCLA, who is outcomes, non-randomized observational researcher. And he wrote a great editorial in JAMA Cardiology several years ago called Randomization, There Is No Substitute. And thus far, there isn't. As a total aside, I've been invited up to Harvard School of Public Health in April. They're going to have a day-long symposia on causal inference from non-randomized data, and I think I've been invited as the appetizer to take the other side.
Is that big or not?
It is. So it'll be an interesting. I'll report back.
If you survive.
So it is a topic I indeed. Now, having said all of that, I look at this as, I've been trained both in observational research methods and the methods of clinical trials, and I use them both, as do most clinical researchers, as do, I suspect, many of you, that you need them both. But if you want to compare A to B, you got to randomize. If you actually want to know, is one better, is one worse, are they the same, or are they likely to be the same? I mean, there's just to date, there's been no computational substitute. And if that, I'm sure that somebody in the room is an expert on causal inference from non-randomized data and will tell me that I'm wrong, but I'm not.
I think the more they learn, the more they'll actually realize. I saw a hand here, and then we'll come over here. Okay.
You alluded to this, that sometimes there's a lot of math that goes into maybe bad questions. And on the other side, there are very interesting clinical questions that are technologically infeasible. And it sounds like that one of the unique properties of DCRI was almost a 50-50 split quants and clinicians.
Yeah.
How do you incentivize that and kind of make everyone play nice and encourage that instead of having, only math people and only clinicians in their own room?
Oh. So in my next life, I'm going to start a medical school and teach doctors what they really need to know. And none of it is going to look like the curriculum of today. I got in trouble shortly. Well, I'll tell you the story. I got in trouble shortly after I got here because I went to dinner with a bunch of famous biochemists, and I asked the question. I said, why do we even teach biochemistry to medical students? And they looked at me and shook their heads. Then they said, well, what do you mean? I said, well, look, I'm the chair of medicine. I couldn't even tell you what the Krebs cycle is. Like, I can look it up, and I know it has something to do with energy, but like, what else I don't need to know much more to practice medicine. Oh God, the next day I got a phone call that said, Bob, did you really say? We got like 4 Nobel Prizes. And I said, I wasn't denigrating the science of it. I was asking the question, do clinical people need to know that? Because what clinical people really need to know is math. And they need to know psychology, and they need to know anthropology, and they need to know communication skills. And yeah, they need to have a science foundation, but do they really need like a semester of biochemistry? So I think what we have. Oh, am I gonna get in trouble? So what we really need to do is really rethink, and I think there's some great efforts underway, right? So in the undergraduate, they now have this new major of biomedical computation, and as I understand it, in talking to them, is they're interested in bringing the hum bio kid into the same atmosphere as the computer science kid. That's a great idea, because one of the reasons the data bank worked, my office was right next door to Carrie Lee's, great clinical trials biostatistician. And next to that was a clinician, and next to that was another biostatistician. So one of Caleb's great geniuses was putting people from really different backgrounds together so that we could learn from each other. And that's what the place was like. And so that's what I would like to see, is more of that. You know, we can joke about nobody's coming to work anyways if the buildings are empty. I was at DCRI recently, because I was there for a Duke basketball game, but I stopped by DCRI, and the building was half empty. And it really depressed me, because what the great magic of the place was getting clinicians to hang out with data people. And what I fear as time goes on, that cultural aspect of it will be lost. The whole intention, and Mark knows this, of what our original hope was, is that this building would be full of quantitative and clinical people. And that was the hope, is that we would get those kind of people here intermingling and coming to conferences like this and bumping into each other in the hallway. And I'm still hopeful. I almost never run out of hope. And I'm still hopeful that we can do that. And if you have ideas for how we could facilitate it in the department, let me know, because I would invest in that. We really want to figure it out. And I do think the best way is get people hanging out together and talking.
So quickly, I think we could also have data people who have the opportunity to experience life in the medical training world.
Yes.
Not just medical people getting training in quantitative methods,
Yeah.
but I shadowed some doctors, and it was some of the most informative time, and I would like a way to do that again.
When I was in the cath lab at Duke, we do that I would bring my biostatistical colleagues over to the cath lab all the time. And every summer for years, NC State, as you know, has a great biostats program, and I taught in their summer and biostatistics program. And in that program, these were all like high school and early college kids. I would bring them all to the cath lab, and we would spend a day in the Duke cath lab, and I would talk about how clinical people use data to make decisions. And we would watch cases live. Yeah. And you'd see multivessel disease, and we'd talk about the data on multivessel disease versus single vessel disease, bypass versus angioplasty. And I agree with you. And I like nothing better than bringing people into the clinical environment. So yeah, let's happy to think about things like that.
I think I saw Higgins, and I saw Ron. Everybody else had their hand up. Just put it in the queue. Me? Yeah, yes.
Did your time at Duke overlap with David Eddy?
Give me some more context, because the name's ringing a bell.
Cancer screening.
I know who it is, but interesting, cancer was not part of the DCRI.
Okay. David is my thesis advisor here. And then after I finished, coincidentally, he went to Duke.
Okay.
Program. Well, now I think he's living in Jacksonville, someplace like that. The reason I bring him up is your comments about clinical trials. Nobody's arguing that many questions you really can only understand with a randomized clinical trial. However, David's work was in cancer screening. If you think about that problem, if you manipulate a cancer screening protocol and you want to use a randomized clinical trial, you will get your answer at a time frame that's beyond the technology you're using. So some questions you simply can't answer that.
Very fair, very fair. And there's other questions in this, right? Like some of the preventive measures that you apply in public health settings. Like, we need a randomized trial to know that smoking was not good. Probably not. And you go back to the early reports, right, of Dahl and Pito and others, and they wrote a lot on when you didn't need randomized trials. I agree with you. I agree with you. And cancer, there's a whole other body of work on like preventive measures in children. Like you can't do the study long enough to get the answer. Your point's well taken. Yeah.
Hi, I'm Shuchi. I'm a nephrologist. I wanted to
I
ask
knew
a
that,
question
Shuchi.
about, thanks all. This is great. And it's really nice how it's an arc and also a circle, you know, it's really nice that, you know, we are thinking about similar issues as some great geniuses of a while ago. But one of the questions that I wanted to ask was about data quality and get your thoughts on that. It's kind of links back to the equity question as well. When I'm going to talk to a patient about what their outcome is likely to be, even using real world data, they were not represented in the data. If you know weight is not measured appropriately and used in the data set, how can I really trust the data, and how can the patient really trust the data? And it is really expensive and really resource intensive to create data sets that have in real world calibration. And so thoughts on that and
Data quality
resources around that.
Mostly because of my work in clinical trials, I spent a lot of time in data quality issues where you're absolutely right, missing data is a problem. And again, despite all the great work done on things like imputation, missing data is still a problem. Inaccurate data is a problem. Fraud in data is a problem. We used to run all sorts of quality analyses on the big clinical trials, searching for fraud, and we would find it. You know, data that's too perfect. You said get troponin assays every 8 hours for the first 3 days, and when they come in exactly every 8 hours for 3 days, you may have a problem. So you have, so data quality is a big issue, and how do you deal with that? I think different types of data deal with it different ways. Some of it is just, is it really important, or are there substitutes for that data? Are there imputation methods that help? Is it truly, you know, data that's randomly missing? I've been very interested in like these AI algorithms in the healthcare field that show you their model, and then the most important predictor of outcome is missing data. It's like, oh, well, that's not really helpful to me as a clinician. But maybe it was a good math exercise, but it wasn't very helpful to me. So yes, I think that missing data is an issue, that the vastness of data doesn't necessarily replace it. I was on a call earlier today with the Heart Association, thinking about the large scale cardiovascular registries across the country. And one of our limitations with those registries is it's not linked to long-term ambulatory data. And what could we do to get around it? Well, you know, some things you get around it, right? You link it using matching techniques to other data sets, but that's good, but is it good enough? For some stuff it is, but not, I know that you do a lot of work looking at toxins, et cetera, so it may not be good enough work for that. Yeah.
I wanted to build on that question you had asked earlier about that cross-pollination between data scientists and clinicians, and then, you know, the point you made about medical education. Was something that—
Don't tell Lloyd I said.
Well, something that really struck me, I think, about, you know, the title of this talk, and what was interesting is, you know, I feel like with data science and the ability to generate insights and how the insights themselves can impact, you know, medicine, how we practice, but it's also, I think what you're saying is it affects how we think as clinicians, and in some ways redefines what it means to be a clinical expert. I mean, I see this all the time when working with residents. I mean, there is kind of that traditional definition of what clinical expertise is, and the way I remember getting trained in medical school is pattern recognition, association, all that stuff. And, you know, with these capabilities, like that expertise isn't necessarily as relevant anymore. But at the same time, you still kind of have that appreciation of, you know, the first principles of how the human body works. Like even the Krebs cycle is somewhat relevant sometimes, you know, depending on what you're doing.
You could probably draw it,
Yeah.
actually.
Well, I mean, like, you can explain why does someone with alcohol, alcohol lactic acidosis have high lactate? I mean, it's fun to, it's like you have this visceral sense of the mechanisms behind how
Give me
things
30
work.
seconds and I'll tell you.
Well, I guess my question is, given that there is this new frontier of like, I mean, may not completely redefine medical education, we're kind of doing it all the time when we're talking to medical students, like working with residents, we have a chance to actually actively do that. Like, how do you create a way of talking about this opportunity of data science to actually reshape how we think as clinicians, like reshape the meaning of clinical expertise?
So a lot wrapped up into that. I'll go back to as I said, Stead's one of my medical heroes. When he talks about education, if you read his biography, there's a whole chapter on education. And one of his quotes is, education is what you have left after you've forgotten the facts. And what Stead was trying to get you to do is what you're getting to, which is how do you think about the problem? And even if you don't know the action, you don't remember the fact, you can look them up. He would also say, never teach anything that you can look up. He said this in the 70s. Like, that was like going to the encyclopedia and looking it up. So he was thinking very differently. And I think what we don't do well enough in medical school and in residency is teach people how to problem solve as opposed to remember facts. Because facts can be looked up and facts can change or evolve. And I think that's a better way to think about learning. He also would say, I'll give you one more Stead quote, which is, there are those who wander around the wards, and there are those who are doctors. The difference is in having the data. And so he was very much in the mind that having data available made you a better clinician. And so when I make rounds, I'm always asking them, like, look stuff up and let's talk about that. Don't think you have to remember everything, just look it up. And you now have the power in rounds. You can look it up as you walk around. I'm always amazed at how facile the residents and the fellows are with that sort of thing. But just remembering stuff, like, there's some things you have to remember. Most things you don't. But you have to have an approach to how you're going to approach a problem. It's one of the great things I think about internal medicine is that it teaches an approach, which is very different than, say, any orthopedic surgeons in there?
They are broadcasting live, recording only posted.
Let's just leave it to, there's a way that internists think.
Other general questions, or we might, Higgins, go ahead.
One of the, so I got my start about the same time as you did. I was working with Hal Sox here.
Oh, yeah.
We were correcting what I would call a curated data set, trying to see if we could predict what patients presented with a chest pain that eventually were found to have cardiovascular disease. And we would take us a year and 2 research assistants to gather 500 patients with the data, but we could find real information in the data. So it was pretty impressive. Nowadays, of course, data science is basically around big data. And of course, there's no denying the value of that. But I think that it's unfortunate we don't think of the merging of the two. You think about a facility like Stanford, who has a information system they use for managing their data, which is primarily around the collection of these natural data sets. If you could build into those systems for places like Stanford who are interested in these questions, the ability to support the creation of those curated data sets. Patient comes in complaining of chest pain, pop up a question, is this patient a suitable candidate for the study? Get consent. Many doctors won't want to do that, but doctors interested would then collect that uniform data set, which would give us very valuable insight. And when I try to talk to the epigrapher, they come by about once a year to give their talk, they don't even understand that question. Yet it seems rather fundamental, plus especially to a place like this.
Maybe I could call on the chief applied data scientist of Stanford Health.
So we're,
This is the kind of stuff you're thinking about.
Personalization it's coming.
There's multiple issues. Technology-wise, easy to do. In fact, if you use My Health right now, depending on the clinic you visit, between 1 to 6 questionnaires will be thrown at you at a certain point in time and with, depending on where you are. So we can do that. So no technology problem. The question is, who follows through? And do they have an incentive?
And there will be a selection bias from that, yes, I understand.
No. Follows through is in the clinician. Do they have an interest and an incentive? So this is a challenge of an academic medical center. Everybody is trying to create their own little special clinic. And their little cohort of 500,000 patients on which they can have something longitudinal on. Other patients they see, but they don't have a deep interest in. That's the challenge. It's an incentive alignment issue. Recruiting into trials is also the same thing. The trial PI has a lot of interest in recruiting patients. But those patients that are eligible are seen by a bunch of other people who have very little interest. All they want to do is 15 minutes and I'm out of here. So until we solve that incentive problem and we elevate the practice of science on par with the business, we're not going to solve this one. It's not a technology problem.
It's not a technology.
It's a time problem, right? I mean, people just don't have enough time.
And the hope is that we can, with some of these tools, et cetera, one of the things we were getting at and what this computer needs is a doctor is how do we, and Eric Topol, someone was telling me they had Topol in their class recently. What Topol's talking about a lot these days is how do you restore humanism to medicine? And can we free up people's time so they're not doing things that the machine can do for them? And in a way that they can then spend the time thinking about data sets, thinking about research. The other question that I would love to see entertained at Stanford, and I know it's being entertained nationally, is around the whole ethics of clinical research conversation. You know, we let doctors just do what they want to do within some boundaries, but you know, if I go see Ramsey and I have high blood pressure, he's going to prescribe drug A, and I go see me, and I prescribe drug B, and I go see Mark, and I get drug C, and like, why do we allow that? Like, why don't you go see Ramsey and we say, you know, we got drug ABC, we're going to randomize you, and just do it that way and get some learn from the system as you go. Now, yes, I know of all the issues of how clinical research evolved in this country, et cetera, but I think we need to have a fundamental rethinking of research ethics in the country as well. There's a group out of Hopkins who's thinking a lot about this. They actually think it's unethical to let doctors just pick what they want to pick. And without there be the ability to learn from it. That's a whole other topic.
Yeah, Ruth Faden.
Ruth, yeah.
Awesome views on this topic.
Awesome reading coming out of Hastings Center. And I think you're going to see some interesting conversations that appear in sort of the national dialogue around research ethics, around the use of regulatory policy, frameworks of how we think about data in a healthcare system. What's all of our responsibilities to participate? You know, how do you learn from every single patient?
We're pretty much at the end. It's been a fantastic discussion. I certainly hope it won't be the last. We'll do a follow-up. Maybe if you want to have any final words or might think about your vision for the past 10 years has been amazing. What's the next 10 years like? And is it different? Is it changed? Is it addition? Is it the same thing? Is it just more, or is it something we learned from the past 10 years?
No, I think we're now at a point so when I got here, you know, we were a small hospital and clinics, right? SHC stood for Stanford Hospital and Clinics. Now it stands for Stanford Healthcare. And I think that we are a health system now. To me, and that's taken 10 years to get us to this point, right? I think that the next 10 years, let's call it the next 3 to 5 years, Jonathan, are how do we create an environment where we're a model academic healthcare system? And that's going to have to involve different ways of thinking about research, thinking about education, training. That's the next opportunity. And so, you know, I'm really interested in how we're going to do this over the course of the next few years. Again, as Mark and Nigam know, one of the other things I'm very interested in is, can we get more expertise on campus in machine learning and other newer technologies on the faculty? So how do we recruit more clinically trained people who are quants? How do we do that? Or quants who are clinical people? And
Or maybe just have a better way of having the quants communicate with the clinicians, and then it won't be so hard.
another thing that we're talking about. But one of the things that I've been talking to Mark Niggum and Kurt Langlotz and others, how do we bring like a large group of people to campus in a block that could really help drive some of these conversations and who would bring new expertise to campus, et cetera. So more to come.
Fantastic. So
Yeah.
let's once again thank our chair, Dr. Harrington.
Have a meeting.
Thank you so much. Good to see you.